Welcome, and thank you for joining us for the Mirantis OpenStack with PLUMgrid ONS webcast. All of our guests are on mute during this session, so if you have any questions, please use the Q&A window typically located to the right of your screen. We'll be taking breaks throughout the presentation to address any questions that you might have. Let me present to you our hosts for today. First, we have Valentina Alaria, who is the Head of Product and Solutions Marketing at PLUMgrid, and John Jenshik, who is the Technical Solutions Marketing Manager at Mirantis. John is going to kick off this session today, so over to you, John.
Thanks a lot. I am going to be introducing today's session by talking a little bit about OpenStack, which is what Mirantis does. OpenStack is, well, as the slide says, a little confusingly, I think, it's a set of interfaces that abstract APIs for drivers across infrastructure components. But I think I have a better explanation for what it is. It's an open source cloud framework. It comprises a growing list of sub-projects that coordinate the components of an open cloud stack, like hypervisors and containers, like virtual network components and services, virtual storage components, operating systems, compute storage and network hardware, orchestration, telemetry, measurement. And these coordinating components, which have names like Nova Compute and Cinder Block Storage and Neutron Network, use drivers to adapt them to specific infrastructure and solutions. Collectively, they help OpenStack allocate data center resources to serve tenants and workloads. Now, on top of these services, OpenStack provides a set of REST APIs, and these APIs are accessed remotely by a web UI called Horizon, which is fairly comprehensive and sufficient for manual cloud operations. Also, it can be accessed conveniently from anywhere via a set of more comprehensive command line clients written in Python. And then additionally, by means of associated SDKs. So your language or scripting methodology of choice can be accommodated directly and talk to OpenStack. All of this stuff is very useful for managing cloud operations, for diagnosing what's going on with a cluster, and for automating basic tasks with infrastructure. But the APIs obviously are useful for more than just writing little scripts that start 10 or 20 virtual machines. They can be harnessed by orchestrators like the OpenStack project Heat, which lets you template, store templates in repos and revision control, code that enables more complex deployments, including ones that auto-scale. There are also vagrant providers, for example, for OpenStack, which work very well. Providers for other installation and cloud management command line systems and higher level orchestrators like Bosch from Cloud Foundry and other tools. The orchestrators, Heat, for example, can in turn be harnessed by higher order tools like the Murano application catalog, which is a Mirantis independent open source a project that enables self-service delivery of containerized apps and prepackaged environments. And then they can be harnessed by platform as a service solutions like Cloud Foundry, which virtualize the IaaS cloud and enable highly abstracted, efficient delivery and lifecycle management of cloud-native containerized web apps. Customers choose OpenStack, well, for a variety of reasons, and the URL at the bottom of this slide shows a very interesting survey that was conducted through most of last year by the OpenStack Foundation that clarifies both why people chose OpenStack at the beginning of the year and why they were choosing OpenStack at the end of the year. There's been significant movement from smaller implementations, experimental proofs of concept, to large and production scale implementations in a lot of places. Last year was a real watershed year for the project in the enterprise, service provider, and other key spaces. What people are looking for, well, obviously, what we're saying is that they prioritize cost savings. And certainly there are cost savings to be gained by using open source cloud solutions. Although it's easy to overestimate and or misestimate and project those costs long term. Cost, however, is not the fundamental mover. The fundamental mover is is flexibility, openness, that is to say freedom from lock-in, and increased operational efficiency. Where we see in our own implementations, people assigning value is first at the lowest level among developers who are looking for solutions that will let them spin up their own environments, explore integrated environments that abstract away the mechanics of cloud and infrastructure operations in the course of delivering dev, QA, test, and ultimately production sequences. We see a lot of interest in what's been called CI/CD, continuous integration, continuous delivery. Basically, people want to do stuff without worrying about underlying mechanics. They want to take advantage of APIs and abstractions to turn the functions of the cloud into a true commodity. And this has historically, in recent years, been something that people have accomplished with services like AWS, but are finding that they can do with greater customizability and flexibility and ultimately power with OpenStack. Above that layer, of course, there are the IT people who are responsible for putting systems in place and responding to the demands of developers, which can be imperious, and they want to improve their productivity too, and are looking at automation and platform as a service as ways of facilitating the delivery of ready-to-roll dev, QA, test, and ultimately production environments, as well as the ability to dynamically scale environments to meet user demand. And finally, business leaders of various kinds are looking for ways to escape historic lock-in factors that have dominated their choice in data center solutions, and to react in more agile ways to industry and customer demands. They want to be able to add resources quickly. They want to be able to grow their clouds up, or indeed scale them back sometimes to meet demand accurately. And they want to be able to serve what are ultimately turning out to be hard to anticipate developer needs. There's a great deal of ferment now in developer tool design, tool chain design that needs to be accommodated somehow. And OpenStack is proving to be the way that a lot of companies are going to do this. I don't want to dwell too much on this slide because I think that we are all at this point and should be primed to filter hype out. But it's worth noting that over the past couple of years, since the inception of several large-scale open source cloud projects, that OpenStack has been has emerged in the past 2 years, at least, as a consistently dominating and consistently growing phenomenon. It's a very large project. There's over 1,500 people now contributing. A lot of organizations, a lot of companies, including my own, in the number 3 spot with the last revision of OpenStack called Juno, contributed a great deal of code. And a lot of vendors are creating plugins and drivers and add-ons so that user choice is actually being emphasized as the project vision said it should be. A little bit about us. Mirantis is it's actually a fairly old company, but came to the OpenStack market as OpenStack became a project, and OpenStack is now all that Mirantis does. We have over 600 engineers who spend, the majority of whom spend a great deal of their time, and many of them full-time, contributing to the project itself. We start projects that have been accepted by the OpenStack Foundation. In fact, as recently as last night, confirmation of our Rally project for telemetry was distributed around the company, something we're very proud of. We are probably the only pure-play OpenStack company in the market. The other contributors, although they do a great deal of work, have other concerns. They may have proprietary products or other angles on participation in OpenStack. We are uniquely concerned with advancing OpenStack as a method for creating dynamic clouds and promoting user choice. Where we focus a lot of our effort is on a product called Fuel, which is a deployment and management engine for OpenStack. Our work consists of following OpenStack's every 6-month release cycle by working on by creating a distribution which incorporates the core OpenStack code and related projects and select plugins and drivers from partners, as well as a great deal of what we call a configurational hardening code. The configurational hardening is the result of a great deal of experience that Mirantis has implementing clouds for customers. We know how to install OpenStack on a wide variety of hardware and have been very good over many years in maintaining databases of configuration methodologies and specifics, and all of this intelligence is worked into the configurational hardening that we do around OpenStack, fundamentally a job of editing config files into more proper configurations compliant with reference architectures, and in automating the deployment of OpenStack in optimized configurations using our Fuel engine. The nice thing about Fuel is that it enables deployment of OpenStack, which can be a many hours to many days long process if you work directly from sources, reducing it to about an hour. So we produce the Mirantis OpenStack distribution. We do a great deal of training and certification for IT personnel and developers in OpenStack. By the way, our training is 100% vendor agnostic. We use DevStack, in fact, not Mirantis OpenStack in training. And people like our trainings. I have personally sat through several of them, and they are extraordinarily challenging. When you are certified by Mirantis, you really know your stuff. The courses, including our boot camps, are heavily tested, and releases are granted grudgingly. There's really no fooling around with standards. We also have a large solution engineering division that builds clouds for customers, and an associated support division that supports those customers with standard enterprise class up to 24/7, 365 SLAs. Additionally, we have a hosted version of Mirantis OpenStack, nominally referred to as Mirantis OpenStack Express, that provides an easy on-ramp for people who are interested in exploring OpenStack, as well as a solution for people who want a private hosted cloud solution as opposed to a public cloud solution as part of their enterprise continuum of cloud services. I talked a little bit about Fuel before. Fundamentally, that is the major distinguishing factor beyond hardened configuration and all the plugins and drivers. About the Mirantis OpenStack distribution, which is otherwise essentially pure hardened OpenStack, working with Fuel is extraordinarily simple. You install it on a virtual machine from an ISO. It feels very much like installing a Linux. You click some buttons. If you're doing a plain vanilla installation on networked hardware, it discovers all your hardware. You perform some basic node assignments to decide what's going to be a controller, what's going to be a compute node, whether you're going to use high availability redundant controllers or not. And you press the deploy button, and then you walk away and have coffee for about 45 minutes. And you come back and you have an OpenStack cloud. It is actually that simple, and I've done it, 20, 30 times now. And it works better and better with each revision. So I wanted to pass the baton to Valentina, but first to talk a little bit about why networking is complicated in OpenStack. Obviously, in a cloud environment, you have apps and you have tenants that need connectivity and services, and they need, along with connectivity and services, to be assured of isolation for both performance and security. Obviously, you don't want tenants reading each other's traffic, but also you don't want tenants parked next to noisy neighbors and degrading each other's performance. You need uniformly high throughput and the ability to service physical network configurations that allow for redundancy and high performance regardless of the location of workloads. You want the ability to scale your physical infrastructure and your applications smoothly, and you want security and metrics and the ability to comply with SLAs. This is a lot of complicated stuff, and OpenStack all by itself provides for abstracting this stuff in useful ways. You see this illustration, for example, is a Cloud Foundry deployment that I was doing the other day. It looks very simple. It's a gateway, and it's 6 or 7 servers, including an Insertion server, that are sitting on a subnet. This is all happening, however, within a project which may have peer projects and top-level domains, and it's happening within an availability zone. And if I wanted to make this radically bigger, I would begin to run into complexity problems. I would want a solution that went beyond the APIs, the simple scriptability, and the Horizon interface to manage this Cloud Foundry deployment in a realistic way as a production solution. As I said, OpenStack provides these basic services. There is a go-forward network control orchestrator and API called Neutron, which hides SDN in favor of simple abstractions that everybody knows about, like routers, gateways, and subnets. It supports various network models that use VLANs and GRE tunnels and other well-understood tools for creating virtual networks and isolating tenants. It extends via plugins for things like load balancing, VPN as a service, and it incorporates partner drivers to integrate specific SDN components. In default OpenStack implementation, typically we use Open vSwitch as the switching part, but obviously production environments need typically something more. And with that, our contribution here then is to talk agnostically to providers of SDN and to assist them in, where necessary, in creating drivers, plugins, and ultimately fuel plugins to facilitate deployment of their solutions. We run certification programs that assist in testing and CI/CD harness construction and in assuring themselves and ourselves that their solutions work well with OpenStack first and with Mirantis OpenStack second. And then we partner with leading SDN providers to support user choice and ultimately to simplify deployment and ensure customer satisfaction at greater and greater scales. And with that, I'm going to hand over presenting rights to Valentina, who will tell you about PLUMgrid.
Thank you, John. All right, so we're going to switch gear a little bit and start diving a little deeper into OpenStack networking, and then I'll tell you what PLUMgrid does for OpenStack networking. So just, adding up on what John was just describing, the network component for OpenStack, it's called Neutron, and these was introduced a few releases back to really enable both cloud providers and end users, tenants, to self-provision rich network services. So before Neutron, networking was kind of built into Nova, the compute component of OpenStack. And Neutron is really, the component that brings these rich network topologies, the ability to configure, security policies, to interconnect with the external world, provide this isolated environment, and so on and so forth. Now, with Neutron, users can really define their own networks, can define their own IP space, can define how these networks are interconnected with routers, and again, define policies and security, and define how their private isolated environment talks with the external world. So this is, this slide here, it's, and John showed it earlier on as well, it's kind of, the OpenStack representation of networks. And you can see it's very simple, very intuitive. And I'll walk you through a little bit of a demo later on. You'll see, it's very simple to just use the UI of OpenStack to go through all these steps and creation. Now, what is important to understand, and I think that's where there's a lot of confusion, is that Neutron was created from the get-go to be a plugin-based architecture. What this means is that Neutron doesn't really implement the network functionalities. What Neutron is, it's a very thin abstraction layer, an API layer. Exposes constructs like networks, interfaces, subnets, routers, security groups to the end user. And in the backend, talks to whatever implementation of Neutron the customer decides to go and leverage. So this is a very fundamental point. So the backend can be VLAN based if you're using a Neutron plugin that actually goes and configures VLAN on a physical network infrastructure. It can be overlay based if you're using a solution like PLUMgrid. It can be a fabric controller when you're manipulating OpenFlow in your underlying fabric. Whatever that is really what implements the networks and the functionality the user is exposed to Neutron. And so, again, what happens if you're, for example, using an SDN solution, all the API calls and all the definition that you make through Neutron will be passed through all the way to the SDN controller that will then go and implement it. There is kind of a default implementation, which is based on open source components like OVS. And that's where a network node, that's where usually people erroneously think it's Neutron, the Neutron implementation. And this is usually what most people out there start with. It's what it's, included in Mirantis and other distributions. It's kind of the default component. Now, OVS and the network node are, a great starting point. As John earlier on mentioned, when you start looking at how to scale your OpenStack deployment and how to grow and support production use cases, the network is really the key building block that has to have the best level of performance, scalability, rich functionalities. And so when you start with components like OVS and Neutron, and the network node, there is some intrinsic limitations that you're going to run into. So this slide here just gives you an overview of, what are some of the challenges and limitations of the model of OVS plus the network node. If you're not familiar with the network node, the idea there is that the network node, it's a central component, like a server or group of servers. They are implementing the advanced services like NAT and firewalling, load balancing, and so on and so forth. So when you're leveraging an OpenStack deployment that has a network node, the traffic from your hypervisors will have to traverse your infrastructure and get all the way to the network node. And obviously, the network node becomes a bottleneck because you're going to have to funnel all the traffic through that component. And you're going to have to start worrying about, placement of the network node and how to make it highly available, and how to design it in such a way that if you scale out your solution and add more and more and more servers and more virtual machines, your network node doesn't break the entire solution. So, this is usually where customers start engaging with PLUMgrid, and, they look for a solution that is fully distributed. They look for a solution that can scale with their needs. They look for a solution that has kind of the best level of performance. So that's where we jump in, and I'll walk you through what we do to help there. And again, to be crystal clear, what we do is we have a Neutron plugin. So we fit exactly with this model that I've been describing so far. We fit within an OpenStack implementation, and we augment, the functionality that are available with Neutron from the get-go. So this is a very, quick slide on, what PLUMgrid Open Networking Suite is all about. So let's start from the bottom up. The first thing to know and understand is that we are an overlay-based solution. What this means is that we build on top of existing physical infrastructure. It can be any hardware. We have special integrations with specific components that I'll talk about in a second. That's why we mentioned everything Cumulus here. But we can deploy on top of any physical infrastructure. We're overlay based. What that means is that we leverage some form of encapsulation directly from the hypervisor layer to decouple the existing physical fabric from the tenant infrastructure. Now, the reason why this model is very important is because you want to be able to offer isolated multi-tenant networks to the end users of the cloud without having to go and manipulate the physical infrastructure. And we'll discuss more why that's important, but it's really a matter of minimizing changes in the fabric, keeping it very stable, and designing it not for isolation, but for performance, scalability, reliability. So on top of these overlay networks, what we do is we give customers their isolated multi-tenant environments. We call them virtual domains, and we'll talk more about what the virtual domain is, but in a nutshell, a virtual domain is a private, isolated data center that we can give to a user, an application, a tenant, and within this virtual domain, they can define their own network. Really imagine as if you were designing your own physical infrastructure, but now you can do it in this virtual space in software, and you can fully automate it. You can do it on demand, and you have all the flexibility of defining your own private IP space and whatever type of network configuration your application needs. So virtual domains are really the mapping point between your application needs and the infrastructure within your OpenStack cloud. So within a virtual domain, as I said before, you can define any set of network feature and functionality. What is important to understand here is that if you're using PLUMgrid in an OpenStack environment, what you're going to be exposed to is the default consistent OpenStack API and user interface. What this means is that you're going to be exposed to networks and subnets and routers and security groups. And this is the same as if you were to use any other network vendor that has a Neutron plugin. What happens in the backend is we map those constructs on PLUMgrid functionalities. So what PLUMgrid has is PLUMgrid offers a portfolio of network functions, from switching to routing to NAT to security, and that's what we use internally to implement the requirements and requests that come from OpenStack. We'll talk a lot more about the network functions, but this is giving you a feel for what we have in the portfolio. Now, how does somebody consume PLUMgrid ONS? PLUMgrid ONS is integrated with all the major OpenStack distributions. It's OpenStack compatible, and it's integrated and certified with all the major OpenStack distributions. And for those that have an automated installer like Mirantis, what we do is we integrate within the installer framework so that it's easier for somebody to go and deploy OpenStack and then roll all the PLUMgrid components on top of it. So what we do is really helping from an operational perspective with the deployment steps, making it extremely smooth and straightforward to roll out all the pieces on top of what you already have in place, and then help you through the life cycle of your cloud with very simple configuration, automation abilities, and very importantly, something that John mentioned earlier. What we concentrate on is, on one side, giving you a very scalable infrastructure, so the ability to grow your OpenStack cloud and have the network grow with it. And the other important aspect is that we have built high availability into every component of the system. And again, this is particularly important when you're running a large-scale cloud environment. So we make highly available all the components from the control plane, to the data plane, and so on and so forth. Let's go a little more deep into the virtual domains. And so what is it? What is virtual domain, and why is this construct so important? And again, this construct is something that our customers are exposed to kind of under the covers. And virtual domains enable customers to build more advanced use cases than what can be mapped on just basic Neutron API. So it's important to kind of get a feel for what a virtual domain is and how it can be used. And again, I'll give a glimpse of it in the demo as well. So virtual domains give this isolated environment to tenants. So when you define a virtual domain, you define what the network looks like for an application. And you're also going to define which workloads will be part of this virtual domain. Now, PLUMgrid has a very broad platform reach in that as part of the virtual domain, we can connect virtual machines that are sitting on a KVM environment. We can connect virtual machines that are sitting on an ESX environment. We can connect physical kind of bare metal workloads as part of a virtual domain. We can connect, container-based workloads. A virtual domain has this very broad range of this, virtual network layer that can, stretch and interconnect all these components smoothly connect together. So it's up to the user to define, what the policies are to have, which workloads be part of this virtual domain. And the virtual domain construct, as I mentioned earlier, it's completely decoupled from the underlying infrastructure, given to the fact that we use, overlay technologies. And virtual domains are fully distributed. We'll talk a lot more about it on a couple of slides later. This is just a table. I'm not going to go through all of it, but this is just a table that shows you all the network functions that PLUMgrid provides as part of a virtual domain. So, switching, routing, the ACP, the ability to do NAT, the ability to do security policies, DNS, PVDAN, as well as the ability to interconnect and compose virtual domains among each other. Again, this is very much advanced use cases, but this is something that every customer of ours leverages. Now, what is important to remember, if you have to have one takeaway from this slide, is that PLUMgrid has a very broad and rich portfolio of network functions, and all the network functions that we provide are fully distributed. What this means is that we have a software component that we deploy within each hypervisor in the kernel. And through this software component, which we call the IOvisor, we make every feature and functionality that we expose to a customer fully distributed, so that if you have 2 servers, your network functions can scale across 2 servers. If you have 250 servers, your network functions will automatically scale across 250 servers. So this distributed and scale out architecture is really, the #1 reason why customers look at PLUMgrid in a production environment. Scale out and distributed means performance, means simpler design, means, not having to have bottlenecks. So it's fundamental, and this is something that kind of a default Neutron with OVS and network node does not support, because only some of the functions are distributed while others are implemented through the network node itself. Now, obviously, PLUMgrid cannot boil the ocean and recreate every network functions out there. So what we do is we work with partners to help our customers, integrate and complement the virtual domain functionalities through their offerings. This is particularly important for enterprise customers that already have service assets. They've made a purchase of firewalls and load balancers, your Palo Alto networks, your F5s, and so on and so forth. And they now want to leverage them as part of a cloud offering. So what PLUMgrid does is we have a very pure play open approach where we create an ecosystem around our virtual domains through a service insertion architecture framework that we have. So we can very easily onboard third-party component as part of a virtual domain and expose it in a cloud automated environment. So we service chain and stitch, switch load balancers, firewalls, and components into a virtual domain, and we make that available to the end users. Now, if we just dig a little deeper to give you a feel for how we make all this, magic distribution and performance happen, there's kind of 3 pieces of the puzzle. So the first one is what we call the PLUMgrid director. Think about the PLUMgrid director as the brain of the PLUMgrid system. It's always deployed as a cluster, so it's fully highly available. And the PLUMgrid director implements all the control plane and management functions of the system. So it's the one piece that talks to OpenStack. It's the one piece that has a definition of all your tenant networks. And it's the one that is responsible to talking to all, to read the distributed system, all the data planes, all the compute nodes that are out there. The second piece of the puzzle is what we call the PLUMgrid IOVisor Edge. So the PLUMgrid IOVisor Edge, it's, as I said earlier, it's a kernel module. It's our, we have developed this piece of software. It's integrated within each hypervisor. It can be, again, as I said earlier, it doesn't have to be just your KVM hypervisor. It can be, ESXi as well. And the IOVisor Edge is really the point, the component that makes the distributed functions possible. And so whenever you define your virtual domains, your networks through OpenStack, what happens is the IOVisor address within each of the compute nodes will be the one implementing, switching, routing, NAT, and security, and so on and so forth. The IOVisor has been upstreamed, so it's available to the community. And this is really kind of a key component of the solution here. Now the IOVisor Edge is what provides connectivity to virtual machines and containers. And we also have another flavor of the IOVisor, which is what we call the gateway. If you're familiar with overlay networks, the gateway is always the component that maps from overlay to external network. And so we have the ability to run this gateway function in software. So it's just a server on which we deploy, an image. We also have integration with, partners like Aristas and others that provide physical switches that are VXLAN capable. So really offering an array of features and functionality, and performance choices whenever you decide to deploy PLUMgrid ONS. So this slide is not going to work in this format here. We talked about it anyway. And so what we do, as I said earlier, we map OpenStack networks to virtual domains, and that's kind of the translation of the two constructs. And I'll show you in the demo what that means. But you're gonna, through OpenStack, you're gonna define your OpenStack networks, and under the covers, through our UI and our API, you can consume kind of the PLUMgrid representation of it. Now, the reason why we have built virtual domains and give these representation is because if you're operating a large-scale environment and want to know what your network infrastructure is doing, you need a lot more visibility and information than what OpenStack default provides. So through PLUMgrid, our users can get very detailed information about any interface in this virtual network, packets flowing, drops, and we've also built a very rich set of tools, what we call PLUMgrid Toolbox, that help monitor and troubleshoot in real time the network infrastructure. And so this is kind of an important operational component because the virtual network infrastructure, it's again, the junction point of your compute and storage is what provides connectivity and isolation. And you want to make sure that you can proactively react to any problems or failures in your infrastructure. So the way we augment the default functionality available in Neutron is it's really adding these troubleshooting tools and monitoring tools and giving you a whole new level of visibility into your environment. So this is the last slide, kind of summarizing the architectural benefits of PLUMgrid on top of kind of the Neutron architecture. And so really the ability to have all the network functions be fully distributed. So the VM's packet flows never have to travel to any central location. And then, all the high availability and redundancy that is built in the system. So when customers ask us, why would I go with, one flavor versus the other? I have a lot of customers that are, still using Nova networks. I have, lots of customers that have been, toying with OVS, and they ask us, why do I move to PLUMgrid? Why should I choose PLUMgrid? So really, when you are in a mission critical, large scale environment, there's need for scalability, performance, and feature set that PLUMgrid can satisfy. And then from an operational perspective, operational angle, all the tools and visibility that we have built on top of our product, as well as all the automated installation and simplified configuration. That's really something that helps bootstrap the creation of a new business and simplifies the adoption of OpenStack. So this concludes the presentation part. There is some links to documentation here. John mentioned earlier that OpenStack has a hosted environment that you can go and try out. We offer as well a sandbox, virtual sandbox, as well as a hosted environment. It's called PLUMgrid Ignition, and you can check it out. The link is here. Both are great ways to get started with both OpenStack as well as obviously the network component of OpenStack. I can start the demo video, and then I see there's a few questions that we can address as well. And we don't have to go through the whole thing, but just to give you a feel for how things work. So this environment, it's a PLUMgrid environment that was deployed on top of Mirantis OpenStack. What we're showing here is just some very basic operations that can be performed through the OpenStack user interface dashboard, what is called Horizon. So as you can see here, I'm logged in as a tenant. And what I'm going to do is just going to create a very simple network infrastructure. Depending on the application you're running, this example here, I'm just going to create kind of two separate networks for my web and database tier. And what I'm going to do through OpenStack here is to define my own private IP space. Again, because we're leveraging in the backend an overlay solution, you can define any IP space that you want. And this is your private IP space. It's completely decoupled from the underlying physical infrastructure. And the overlay network takes care of, just isolating all of this information from the underlying infrastructure. Now, when you switch over from OpenStack to PLUMgrid, you're going to have a slightly different, visibility of things. You're going to see your, PLUMgrid representation where you have, these switches and virtual machines information and so on and so forth. And as I mentioned earlier, in the PLUMgrid view is where you can get all your more advanced, troubleshooting information, interfaces information, and all sort of things that are necessary to actually operate the fabric. And then some of our customers leverage PLUMgrid API directly to augment some of the OpenStack offerings. So if you want to automate and have directly NAT configurations or other components that are not present in OpenStack, they leverage our API directly. So here we're adding some virtual machines to each of the networks that I had created. As you can see, it's very straightforward. You launch a virtual machine and you select which network you want to use for it. PLUMgrid has integration with the compute layer with Nova. So every time a VM comes up, we are aware of it, and we can provide and provision on demand the network infrastructure that this VM needs. And then here, what I'm doing is now adding a router so that I can interconnect my two networks, as you can see on the OpenStack representation. And similarly, you can see it on the PLUMgrid representation. So we now have our router. We also have metadata services, which is more of an advanced component in OpenStack that we're not going to cover today. But you see, it's extremely simple to create and provision any type of infrastructure. So really, cloud use cases drive this need for agility and provision in seconds of the network component. And OpenStack provides this very flexible framework for you to expose this functionality to the users, and PLUMgrid in the backend makes all these features possible by making them distributed and available across the entire infrastructure, and extremely simple to expose to the end consumer of the cloud. So here we're just verifying that obviously virtual machines can connect to each other through the routing infrastructure. The last piece of the puzzle when you deploy an OpenStack network is to have it talk to the external world. So this ties back to what I was describing earlier in terms of gateway functionality. And in OpenStack network, the high-level construct that is exposed to the tenant and the cloud operator is the construct of external network. So the admin of the cloud will define this external network. And what this means is that it's going to define kind of the exit point for a tenant onto the existing physical infrastructure. So up until here, everything we were doing was in this isolated private space. I have my own IP addresses. I have my own topology. I can have as many routers as I want, as many networks as I want. It's mine. I do whatever I want. The exit point into the physical network is that it's something that is not controlled by the tenant. It's controlled by the admin. So the admin is the one that is responsible of providing this external connectivity, exposes it to the tenant, and then the tenant will be able to just tell his own network, his own router, hey, to exit from the infrastructure, use these external connectivity point that the cloud operator has given me. So this gives you, a feel for what we can do here. I want to pause for a second and check and make sure how we're doing on questions, and I don't want to go too long. I want to make sure that we have time for questions. Just kind of wrapping up the demo, I can leave it running in as we start addressing questions. There's some videos around the tools that we provide and stuff. We can leave it in the background as we we start talking about what people ask in the Q&A panel. How about that, Admir?
That sounds great, Valentina.
Yeah.
Let's jump into questions. So let's see here. There's a question that came in from the audience, and it was about how PLUMgrid ONS compares to VMware NSX. And I actually would like to zoom out a little bit and just as a general level, how does PLUMgrid compare to OVS-based solutions that leverage OpenFlow?
Absolutely, that's a great question. So there's some key architectural differences that I briefly touched upon as I was going through the slides. But the way to think about OVS versus the IOVisor is that OVS is, first of all, an OpenFlow-based data plane. So what this means is that it was designed from the beginning to be able to satisfy OpenFlow rules and be able to match packets based on specific rules and fields. Now, OVS and anything that it's leveraging, OVS, so obviously NSX and other products. What that means is that there's always a need to punt packets to some either user space or controller component whenever there's no entry for that packet. So the first consideration is that the performance of such an approach is such that most of the time you're going to have to punt packets somewhere else to resolve what you have to do with that packet. So kind of that's the first limitation of that approach. The second limitation of really any data plane is not just OVS compared to the IOVisor, is that any data plane out there, it's hard-coded to provide some set of functionality. And so when you hard-code a data plane to provide some set of functionality, what this means is that if you evolve and you start, you need to add more functionalities, you need to now add security or load balancing or whatever else, and throw that into the mix, you need to go and modify completely your data plane. So usually what that means for a consumer of this technology is you're going to have to go and patch your data plane, have a complete reboot of your cloud, and it's going to take quite a long time also to develop this new functionality. The IOVisor was always designed from the get-go to be extensible at runtime. So the IOVisor is a flexible data plane where we can load network functionalities as needed. So it's a big fundamental architectural difference there.
And I think one thing that you and I hear about, I know Mirantis is called, pure play OpenStack player. I think, PLUMgrid gets called as the no agenda SDN player. And really, I think that speaks to how open we are relative to the kind of OpenStack distributions that we're integrated with, Mirantis being one of them. And then also the types of hardware and virtual appliance and Docker containers that we can ingest into our fabric and make that available as a network function. So I think that's really a key differentiator for us too, relative to VMware NSX, where that tends to be something that's fairly focused on either particular use case or particular infrastructure components that limits you in terms of flexibility in this era of cloud where there's a lot of moving parts. And so we tend to take the pragmatic approach that says, look, we accept all comers and really try to help customers sort of go from where they are right now to where they need to go in the future, make it really extensible, very, very flexible. But that was a great question. I'm going to pass it on to John. Hey, John, so how does Mirantis OpenStack support highly available and distributed storage?
Well, there are a couple of solutions that Mirantis OpenStack supports out of the box. You can, when deploying a cloud with Fuel, make a decision whether to use OpenStack legacy object storage system Swift or switch to Ceph, and you can selectively determine whether to use Ceph or Swift to provide just object storage to your cluster or both object and block storage. So you can make all of your storage distributable. In addition, we recently released in a sort of an uncertified state a GlusterFS plugin for Fuel that makes it possible to easily deploy GlusterFS equivalently as distributed storage anywhere you want distributed storage in an OpenStack cluster. So pretty broad. I guess alternative solutions would require a little more manual integration at this point, but we're always adding new stuff.
Got it. Excellent. How about migration? Obviously, their customers are using virtual machines today in a non-OpenStack environment. How much work is it to migrate applications to OpenStack and take advantage of this new modern architecture?
I guess that's for me again.
Yeah, that's for you.
This is an interesting question right now because last Friday closed an OpenStack Foundation project, a book sprint project, to create a definitive book out of the OpenStack community on creating applications, architecting applications for OpenStack Cloud. And this was done by a bunch of volunteers, including Mirantis Nick Chase, who served in an editorial capacity. It was conducted in Taiwan, but with participants remoting and helicoptering and Skyping in from around the world. And I would expect that inside of 2 weeks or so, that book will actually be available in draft form, probably free of charge, as earlier book sprint books like the Architecture Design Guide have been. So if you really want the definitive answer on community-wide, this is how cloud apps should be architected, best practice stuff, please get that book. In the meantime, first off, OpenStack, and in particular Mirantis OpenStack, because of our partnership with people like VMware, is moving into a position to support multiple hypervisors. So if you absolutely positively need your ESXi hypervisor to support your HA-dependent legacy applications, you can have that, and you can have your OpenStack APIs as well. I guess you would call that a zero portability solution. There are importing stuff to KVM, which is this more, the open source sort of native preferred, if it's possible to say, hypervisor for OpenStack. You're looking at needing to provide HA as a software solution, which the OpenStack community tends to do with its own components via HA proxy and RabbitMQ for load balancing and systems. There's a standard practice that segregates stuff to availability zones and so minimizes points of failure within a cluster, and uses these open source tools to to balance and determine which to arbitrate master-slave, active, passive kind of configurations. A lot of apps do that already. Web-native apps tend to. If you're working with platform as a service solutions, moreover, like Cloud Foundry, the HA is something that you can dial in the abstraction of the platform, so you don't really have to worry about it at that point. Ultimately, it's easier than you look, except in specific use cases where it turns out to be complicated. And there are some OpenStack, open source, I should say, projects closely associated with OpenStack, like Pump House, that facilitate, for example, extraction of AWS workloads. I know that Eucalyptus did some work extracting AWS workloads and has powerful solutions. So there are point solutions to solve most of the use cases that people will encounter in migration.
Excellent. Thanks, John. I think we'll take one more before we end the webinar today, and this goes to Valentina. So, can PLUMgrid Neutron plugin run concurrently with plugins from other networking vendors? Right back to the question around being flexible and open.
Yeah, absolutely. And we've done, also work in, integrating and certifying with other components. In particular, I gave you a flavor of, our service insertion architecture, and that's one area where we see PLUMgrid working very closely with our partners. They're leveraging, for example, load balancer as a service or, firewall as a service extensions to Neutron. And so certainly, PLUMgrid has a very open approach, and we work with other components to provide a complete stack solution.
Excellent. All right. I think that's all the time we have today. Thank you, everyone, for joining the webinar. Thank you, John and Valentina, for the great presentation. As I said earlier, we'll go ahead and post the recording of this webinar here in the next week or so. And with that, I'd like to end it, and I hope everybody have a good day. Thank you.